Okay, so this is a week number 12, number first problem, manipulating the equilibrium constant. And let's look at the expression here. So this is a methane. When methane is converted into ethane with a hydrogen. So this is, I guess, a hydrogen generation reaction. And also methane can react with water to make methanol and can generate a hydrogen. And these are the equilibrium constant based on the concentration that is shown up here. And then the question is, can you calculate the Kc for the following reaction shown up below? So let's focus on what we need to obtain here. So then I can see the ethane is shown up located right here. So that's good. That should be fine. But if you look at the methanol shown in the other side, so this is something that I want to start at first. And then I need to flip this equation. So what I need to do is, let me write it this way, CH3OH, methanol with a hydrogen, goes to methane and the water. And then this one is now new Kc, which is the inverse of Kc. Let me just say this is a Kc1 and Kc2, and this is a Kc2, which is a new inverse one. Okay, so that's a new Kc, which is an inverse of the previous reaction. And then I also noticed that there is a constant 2 goes in front, whereas this one is just only 1. So not only you have to flip the equation, you also need to multiply this equation by factor of 2. And what it does is this equation should have the square of those values once you do that. So finally, what's the equation that I'm seeing now as a consequence is 2 times methanol, 2 times hydrogen, 2 times methane, and 2 times H2O. And then the Kc prime value for particular equation written in purple is a Kc, the equation number 2 shown up, and multiply by the square. Okay, so that's the one equation that I like to have, and so that's now I have a nicely matching position of 2 methanol shown up below. And then so now let's go and write the same equation shown up top, and then that's the one, say 2 methane goes to C2H6 ethane with hydrogen. And in this case is Kc for this second one, which is same as the one that you shown up here, right? The first one, the one Kc1. Okay, so far so good. And then now we're going to just add them up to see what we have. This one goes away, and the hydrogen goes away, and what's left here is 2 methanol, and then this one survives, so H2 goes C2H6 to 2H2O. So that is a new Kc value that is in question. So therefore, the Kc for the equation above should be Kc1 multiply 1 over Kc2 to the square. Okay? So Kc1 is 9.5 10 to the minus 13, and then 2.8 10 to the minus 21 to the square. So then what I'm going to write it is 9.5 and 2.8 to the square, 10 to the minus 13 plus 2 times 21 is 42, right? So that's the number that you will have. And then if you calculate this one, you will get the 1.2 10 to the 29. So that's a KC. So what this actually also, just I guess extra comments on that I would like to make a note here is, if you look at this concentration based on this value, this is a very, very small numbers. So they heavily favor those methane compared to ethane or methanol production. But however, when you have a methanol, put it into the hydrogen, you can essentially generate the ethane, and that one is pretty heavily favor the products, because that's a proportion between the products and the reactants. And then when KC is really large, they prefer to produce the product, and that's from the equilibrium constant perspective. Thank you for your attention.